So we have a AMC 12 problem today. So we have polynomial with the fourth degree has a real coefficient. So let's highlight this. And f of 2I and f of 2 plus I is 0. This is actually telling a lot of stuff for us. And now we want to find the sum of the coefficients of these terms. Like when we have f of something equals 0, like that means 2I is a root. Okay, so a root, so which is like you can remember the factor theorem. So if that is like f of something is equal to 0, so which will be our remainder is 0, which means f of 2I is 0, which is 2I is like solution basically. And the same reasoning, 2 plus I is also another solution. And since we are told this polynomial has real coefficient, when we have real coefficient of any polynomial, the complex roots comes in conjugate. So we have 2I as a root, so 2 plus I is another root, so which means we already know the other two roots has to be negative 2I and 2 minus I, because they're going to be coming in conjugate. So now we can just say if we have like the highest degree term coefficient is like 1, which is the monic, so then I can use these four roots to write my polynomial. So the x minus like root, which is x minus 2I, is going to be a factor to get negative 2I to be root, and x minus 2I, which is the another root, will be another factor, and then x minus 2 minus I will be another factor, and then x minus 2 plus I will be another factor. So when we multiply these, we should be getting 0. So let's clean a bit. So the first one is x plus 2I, and this is going to be x minus 2I. And if you expand this negative, so you will get x minus 2 plus I. And then the next one, x minus 2 minus I. And this is equal to 0. So like you can expand this, but let's use our distance, like difference of square. So the first two, like a minus b, a plus b, so which we can just say a squared minus b squared by the distance difference of square. So which will give us x squared minus the square. This time this will be negative 4 times I squared, which is going to be just a positive 4. Again, if you don't get this immediately, go ahead and expand them and see if that's really the case. And the same idea, I'm going to take these as my a, and then I and minus I will be our kind of like b merging, a minus b and a plus b. Just imagine that way. So that will be x minus 2 squared minus I squared. So let's keep this in here. And then this is equal to 0. Again, this is also a difference of square by using these two factors. So the first one is x squared plus 4. And then the next one is if we expand this square binomial, so x squared minus 4x plus 4. But this is going to be negative 1, but there is also another negative, so that should be plus 1. So it's equal to 0. And the goal is just to get the ABCD, so we want to expand these. So let's go ahead and do that. X squared plus 4 and x squared minus 4x plus 5. So this is equal to 0. So now we can expand them. So x squared times x squared will be x to the 4. And then x squared times this will be negative 4x cubed. And then this times 5 will be 5x squared. And then 4 times x squared will be 4x squared. And then 4 times negative 4x will be 16x. And then the last one is just 20. And if I simplify this a bit, so you will get negative 4x cubed. That's the only cube term. And then 5 and 4, which is 9x squared. And then minus 16x and 20. So we got the polynomial itself. So we want to find the sum of those a, b, c, d's. So negative 4 plus 9 minus 16 plus 20. So we have this is 5, negative 11, right? So, and then plus 20, it's just 9. Okay, so we got the sum of the solution. Like we can just do that like negative 4, negative 16, that's 20. Actually, yeah, that's 9. So this is one way to do this problem. So you can just like use this information, find the other two roots, which we did, and then just write the each like factor by using those roots. And when you simplify, we got the answer. But we can do this question slightly differently, which is going to be a bit better than this approach. But this is still a good way to try these questions. The second approach we can try, like since we want to find the sum of these A, B, C, Ds, like if you look at the polynomial that we have, if I want to plug x equals 1, so you will get 1 plus A plus B plus C plus D. And that means A, B, C, D is like 1 plus A, B, C, D is f of 1. So as soon as we have the polynomial itself, so which was like this guy, right? So let me write this. F of x was equal to x, like I can use this one or that one, which doesn't matter. So the x plus 2i, x minus 2i, and then we got these guys, which is gonna be x minus 2 plus i, and then x minus 2 minus I. So since we want to find the f of 1, if I know the f of 1, then I will find A, B, C, D as well. So f of 1, let me plug 1 for x, so that should be f of 1 equals 1 plus 2i. So like we could just use this one maybe because that's kind of easier, which is why we just need to simplify this a bit. But when you do so, this expression was the same as this. So I'm going to say this is going to be 1 squared plus 4, which is going to give us 5. And the next one would be the x squared, like we got this x squared minus 4x plus 4 plus 1, right? So we just plug 1 for the x. So that will be 1 minus 4 plus 5, which would be this 1 minus 4 plus 5. Again, this is the same as this one we already like showed there. And now this is 5. And then this is like 2, which means f of 1 is just 10. So as soon as we have f of 1, which is like 10, 10 equals 1 plus what we want. So which means what we want is going to be 9. So the second approach is kind of a bit easier than this guy. So because we don't really need to multiply as we did right here. But the first step is still the same. So you can use either way. Okay, so I hope that was clear. So this is a complex root problem. I hope that was obvious. Okay, I'll see you next time.